Hi everybody, Andrew here from DCS and I'm here in Oklahoma City at Reference Analog, and I just wanted to tell you a little bit about the Lina DAC here. So this is our least expensive product in our line. It's the baby in the family, you could say, but it's actually the most sophisticated construction of any of our products, and I just wanted to take you through that a little bit. So if I take off the base plate here, we can see the transformer mounted inside, and I guess this is already you can see some of what I'm talking about here. So this base plate, like the whole of the rest of the chassis, has been milled from a solid billet of aluminium. So this recess where the transformer is mounted has been milled down. This was originally a billet this thick, and I don't know if the camera picks it up, but you can see the milling lines here on the inside. So this gives it it's a very rigid construction. Has a much lower resonant frequency than if we'd used a flat plate, which is how our third generation products are constructed. That was pretty much the state of the art, was using thick aluminium plates put together as a box. And then one of our chassis suppliers came to us and said, "Hey guys, there's a better way. We've got a more advanced construction technique that you could look at." And if you see here, we have the transformer is actually mounted on these little turrets called standoffs. And in a plate construction, these would be separate parts, separate details. You have a bolt going through from underneath and then a nut on the top side. Whereas here you can see we've been able to mill the turrets, the standoffs, into this chassis plate. So this chassis plate is basically custom made to accept the components that are going to be inside it. We've got another standoff here for the P-clip that's holding the transformer wires. If I pull the faceplate off, again you can see the same thing. The mounting areas for the bolts have been milled in. This is the display on the outside that's been milled out of the inner plate here. And likewise, these are milled from solid billets, so they're very rigid mechanically. Just take the rear plate off here. I think you can see better here the way that the plate has been custom milled to accept the connector receptacles, been drilled out for the mounting screws and bolts for those receptacles. And also milled out with more standoffs for bolts that mount the plates together. So this is this milled from solid construction. And by the way, I'll just take the board out here. We've got this insulating layer in between. So this is the top of the unit and the two side plates. And once again, this whole single piece has been milled out of a single block of aluminium. So all this material here in between has been removed. That actually gets recycled, by the way, so that material is not wasted. And what we're left with is an extremely rigid sort of clamshell construction. Here you can see more of the mounting details that have been milled into the to the top plate there. So this is a more advanced construction than the flat plate construction that we used previously. It's more expensive, but it has some benefits for us. The mechanical rigidity, but most importantly, the way that we can tailor make the chassis to receive the circuit board that's going to be inside. I'll come back to that in just a little while. The other piece I wanted to show you is the circuit board. So this kind of, on the face of it, it looks like 5 separate boards. And in our previous generation products, this would have been 5 separate boards. We used a modular construction with discrete boards, and they would have been connected by ribbon cables and interboard interconnects. This was an innovation that came from our board supplier. They came to us and said, well, there's a better way of doing this that you might want to look at. So this construction, this is a single circuit. So this is one board where the solid substrate has been removed on these 4 axes. And this is a 12-layer board, I believe. So there are multiple layers of conductors going through this board. And all of those layers of conductors are continuous from here to here, from here to here. But on these axes of flex, they've been encapsulated in a resin material that's flexible. So this is a single board, but actually has 4 axes of flex. So we can take this board, which I believe is a 30 by 50 centimeter board, we can fold it up and essentially put it in a shoebox. So this construction has a number of benefits over the previous modular construction. The first is an electrical benefit. Anytime you have 2 materials joining in a circuit, so for instance, a ribbon connector, which is basically like a comb, a set of prongs with some springs that clip down on top of them. Anytime you get 2 materials joining like that, you get a small impedance mismatch in the circuit. If you do it properly, you get a very, very small one, but it's still there. With the single circuit board construction, we have a continuous circuit from both sides of the board, so we have no joins. And so the impedance on each plane of conductor within this board is completely uniform across the entire board, which gives us real advantages. Anytime you get an impedance mismatch, you get a small signal reflection as a result of that, which leads to distortion and noise in the circuit, which is eliminated with this single circuit construction. The other benefits of this construction are obviously some packaging benefits. We can fold the ball up and put it into a smaller chassis. We can also take advantage of some of the benefits of the milled from solid construction. So let's just say we've got some output devices over here. Where are they? Output devices. They're here. Yeah, over here. We've got some output devices. If they generate heat, a lot of heat, we could mill the chassis plate underneath them thicker and press them down directly against it and use that as a heat sink. So we could essentially build the heat sink into the chassis. If we've got something sensitive, let's say we've got something sensitive on this board that needs shielding, if we mill a shield into the chassis, then we can just fold this part of the board down behind that shield and essentially incorporate the shield into, again, the chassis plate. So we save having to have discrete parts like heat sinks and shielding components. So we get some real packaging benefits and some real electrical benefits with this construction. But this is, again, it's a more sophisticated construction and a more costly part than the modular parts that we used to use. The really interesting thing, I think, is when we bring these 2 technologies together. So the milled from solid chassis construction with the flex rigid single circuit boards, because the way that we can optimize the chassis to receive the board means that we need far fewer mounting components. We need fewer bolts. We need virtually no nuts because we can tap the receiving holes in the chassis and tighten the bolts directly into them. We don't need discrete heat sinks and shield to the same degree. We can mill those into the chassis itself. And basically we were able to optimize the combination of the 2 in a way that considerably reduced the assembly time of the resulting product. So in our previous generation of products, we would need to mount 2 boards together, test them, add a third board, test that, and basically assemble the component and test it iteratively. Whereas these single boards can be pre-tested at the component supplier before they even come to us, and we know that they're already working. So we've collapsed the assembly time from days down into minutes, which has resulted in a cost saving on the assembly personnel, which more than offsets the cost of the more sophisticated components. So this is actually the most sophisticated construction of any DCS product ever. It's similar construction to that we've used in the VRS, which is our latest flagship product. But this is the least expensive product in our range. So it's something that I think happens quite rarely in electronics and in high-end audio. In making it better, we've actually been able to make it cheaper. And we've been able to reach a price point with the Lina family that we never would have been able to reach with the previous generation of construction techniques. So hope you found that interesting. Thank you very much.